Alrighty then, happy Thursday. First day before the weekend, right? The last day before the weekend, how does it work? We're going to talk about sea level today. We're going to do something a little different. I'll explain it in a bit, but to give you a heads up, we're going to look in the future rather than the past for this exercise and the follow-up on the next assignment. But so that gets to this question, so what? We can talk about, calculate, and all of those things about the sea level, but who cares? And the end result is that the geologic record doesn't tell us too much about that. So we know that there's these transitions. We're talking about a brief part of them. That's getting old hat at this point. This diagram was used as a source of material, and there's a little fine print in it that tripped up some of us. If you read the fine print here, it tells us that it's cubic kilometers for storage, and then they change the font on you. Thousands of cubic kilometers per year for the exchanges or the fluxes. And so there's a bunch of numbers in here, but they're either in regular font or in italics. And the fluxes are the things, the hoses that is moving water, in this case, between two places, between the ocean and the land, or that's going from the land, from the clouds down into the ground. And all of these diagrams have something like this. On this one, the thing that gummed us up as often as not was the conversion to a meter of water. And we really had, well, at least the ones I corrected or looked at this morning, we have you basically either spot on or there was a challenge with the exponent sign. And so we commented appropriately. Any questions on this before we move along? This is a diagram, it's a stylized diagram. Read the fine print, and this thousands cubic kilometers had us confused for a while, but some of us got it sorted out, right? Any diagram should have a good caption to it. And the bottom line is the ice sheets, well, so there's only two reservoirs in the end because our numbers were bigger than anything on this in terms of a reservoir. We could get the ice or we could get groundwater. If you want to worry about fast pace, which we're kind of leaning towards because it's harder to plan for, this is the puppy that you need to get rid of. And you can get rid of that faster than you can change this. Why? Even though there's precipitation into this, the precipitation and percolation that recharges this is a lot slower endeavor. So to get the equivalent amount of here out of here, geologically the processes are sort of an order of magnitude slower. Okay. And then to amplify that, I'm not going to talk about the groundwater anymore, but I am going to talk about the ice to look at the past sea level changes and how fast they had. We're going to get a sort of a number. We're going to come back to that number. How long would it take us to actually get that 1 meter of water change? So you found the water. I want to ask how fast it has. So we're going to look at the past to get some estimates. I'm going to go back to this graph. Well, this is a derivation of the one you saw. It's flipped in time scale, deep past to the present, the rapid rise, slightly different data set. And this was an article, a couple years ago now, about how fast the sea level could go up, and also about things that were going on prior to this, to the time that we've been worried about it. And there's some information in here about the rapid places and whether there's a glitch and other things, and we don't need to worry about that. But we'll go back to the notion that if we started 18,000 years ago and sea level was 122 meters, and then we came up to 7,000 years ago where it was 8 meters below, that means it went up 114 meters in sort of 100 centuries. Rounding it off, we're going to call it a meter rise in 100 years. So our past experience is that the sea level could go up more or less in your lifetime as a meter. I mean, approximately. It's not exact, but it's your lifetime. It's not 5 generations to get it up this level. Exactly how that happens? Well, we've got those two processes of melting and calving. The calving is the far more rapid one. The melting isn't going to get you there. We're going to spend a lot of time about the calving process because it can actually get you that number faster in the next lesson. For today, we're going to take this as an estimate. So 100 years per for meter rise. Got the ice to do it. It happens. It's not a bad estimate. Science is about successive approximations. The fellow who wrote this would call this ludicrous because I'm rounding it down to a sort of a tractable number. He'd want to talk about 1 meter per 123.5 years or something. And he would probably be right. For our purposes, getting the right number of zeros is more important than getting the exact 23 after the decimal point or whatever. So that's a conceptual approach. All right, getting into it right now. The relative sea level is the measured relative sea level is both a part of melting the ice, which we're hammering home, but there's also an thermal expansion. As you warm up water, the area it covers, or the volume it occupies, expands. It just does. And when you take the volumes of the Earth's oceans, they're huge. So it turns out that you've got thousands of meters in the ocean, and you don't have to expand them much to get 1 meter. So rule of thumb is that basically the present day observed sea level rises is about half of this thermal expansion effect and about half of the glacier melt. Ballpark figure. So we'll see that ratio, I mean, we could talk about that ratio changing in the future because of more melt. So we're back to the 1 meter. Everybody comfortable with the 1 meter? We picked the number from the word go, we've calculated it, we now have an approximation, and now we're going to look at a little bit of a diversion here. What's going on along the coasts today? And so there's colored arrows in a bunch of places here. If you look carefully, you can see the tails of the ups and the downs. And so and the ups and the downs, though, you can actually tell it by the colors. Color break is here. Everything over there is going down. Everything over here is coming up. Let's go back to why there would be a variance from different places along the coast of these arrows. Have we seen this before? Have we not seen this before? Have we seen it in a different way? Why would you explain this?
What I'm looking at is the down arrow up over the Hudson Bay, which I think would go back to when you were talking about how it's not necessarily the water that's changing, but the floor that's coming back up after the glaciers.
The floor is coming back up, so the relative water is going down. Okay, so yeah, I always go back to Hudson Bay because it's such a dramatic exercise. There was a picture on the cover of one of the professional magazines 15 years ago of the various shorelines etched into Hudson Bay, and they were arguing there was some sort of some sort of periodicity to them. But this is sort of one of the fastest on the planet. But there are other places. Look at the Gulf of Alaska here. Again, why though? What's the mechanism for the sea level not being constant all over the place?
So the floor could be moving or the water could be moving, or a combination of the two.
Well, and it's this crustal business, but it's the distribution of the crustal business, right? So why might we guess that Alaska has a high number, blue or purple over here someplace, and it's going down? Gentleman in the Cincinnati shirt. You got both got Cincinnati shirts. You've got a gray Cincinnati shirt. Yeah, right. Why would you guess that something on Alaska didn't have a big ice sheet over it? It's still going down.
I'm thinking like when there was like the Bering Strait.
Bering Strait, poorly displayed on this map. They break it off right here. But yeah, okay. So the Bering Strait's an area that was exposed in the last ice age.
So it was so there was more land exposed.
Mm-hmm. But why does that make it faster along here? The area has more to do with tectonics, the fact that the plates are moving around, right? So actually, this plate's moving against Alaska, pushing the land up, so the relative sea level goes up or down. You push it up, the relative sea level is going to go down. Little tricky, these arrows can confuse us once and another. You want to pick a place that you'd like to explain the relative. You wouldn't like to, but you will, but there. So anything that's intriguing pattern that you see. We've been talking about two places where the relative sea level is dropping because the land's rising. But there's a lot of greens on there too, greens and yellows, which means the other side, right? Pick one.
Pacific Ocean. It's
Sorry?
the Pacific Ocean.
Along the Pacific, okay.
Yeah. I just
Which continent we're going to deal with?
South
South
America.
America?
Yeah.
Someplace along here then, right?
Yeah.
What about it?
Well, some trends are like rising, and then some are declining.
They're intermixed, aren't they? So it's not a simple regional pattern. Like this is all about the same coast of the eastern coast of North America. So this wonder what that has to do with, but you do have localized downs for the same reason, tectonics. The way that the crust, parts of these crusts are being driven in, but the island out here isn't, the island out here isn't. This is a local, there's two blues in here actually. So the larger, longer term guesses of the continents, which is really a slow exercise, are dropping things. That doesn't apply to Greenland. All right, anything else we need to know from this diagram? We know this very accurately because all your commerce, most of today, comes by ships. And ships want to have a place where they can go from the deep ocean onto land. And if the change of that position, Matt, is changing, and we're talking about millimeters per year or foot per century, it matters. I mean, there's a place along coastal Maine that if you stand there and look at it, you see this wharf where ships used to tie up to. And now the wharf is below the high tide. So we can't have changed we couldn't have tied up a ship below high tide. So the point is that the land is sinking in that location. So they know this information is known quite accurately. Okay? Boats. So we know what's happening today. None of these are going to be a foot per century, so that's only 0.3 of a meter. But in the past, it was a meter per century. So 3 times what it is today in its maximum. So it has the potential to move faster. All right, we made a quick allusion to this the other day, and I want to reiterate it. Let's see, gentleman in the hat. So I'm sketching different shorelines here. The shoreline's in black or blue. Blue, I think I would represent as the water level. So these are 2 respective land surfaces. Okay, right? And they have different slopes to them. One of them's like that, one of them like that. If I rise that sea level, what's going to happen to these respective 2 different seashores or 2 different coastlines? And I'm going to raise the water against it or lower, it doesn't matter. What's going to happen to them respectively? Excuse me? It could disappear. And which one would disappear first? Excuse me? The one on the right, the way I've drawn it, sure. I mean, I've only extended those faster. Why is that? The angle. And where have we seen this angle thing before? Excuse me?
The last graph.
I still didn't hear, I apologize.
Last graph.
The last draft? Well, I was thinking of the sun's rays radiation. Square on gets a lot, angles spreads it out. Same concept. The sea level is going to go up the same amount on either of the, well, hypothetically the same amount on either of these coasts, but the total amount of the land impacted is going to be quite different. Well, that makes a matter if you're living on this coast or living on this coast. Make some sort of sense? Okay, now the other thing that we worry about in terms of impacts is not just the water level, but what's there on the coast. And so this is my little sketch where we have the same surface slope or the same shoreline slope, but over here you've got a city or infrastructure built up. Over here you don't have so much. So impacts, which one's going to be impacted more? Lady way in the corner. The one with infrastructure or the one without it? I'm sorry? Why would the one without be impacted more? The way I've drawn them, they're going to both get the same, they're both, the total area covered by whatever rise in sea level is going to be the same, right? And what's the difference between this one and this one schematically? This one's got a bunch of buildings, subways, roads, whatever, right? Which one's going to be impacted more? Going to cover the same area, but which one is going to get the newspaper print? Which one's okay. Excuse me? What we had a local temporary rise in sea level along the eastern coast or a couple times this fall as hurricanes went up, right? And hurricanes push waves in front of them, basically. And so the waves are a temporary rise in sea level. They go away after a few hours. But which one did we hear about? The sea level that went up on a gently sloping thing, or where it went up around a city? The cities. So impacts is a kind of a dicey word because the sea level change is the same here. This one you're going to worry about, right? Yeah, because we've artificially constructed things in zones that can be impacted. And this is kind of an interesting point because the impacts we just talked about are the sudden surges because of a hurricane going by, so it goes away in 2 days or 3 days. But those surges can be significant depending on where the tide cycle is, because the tide goes up every day. Well, if you hit the surge when it's down, it just brings it up to high tide. If you hit the surge when it's up, it goes up considerably. And that's when they had several years ago, they had all the flooding in the subway entrances in New York City. The water was high enough to go down into the subways. Nah, they didn't like that. That wasn't a lot of fun. So regardless of what we're going to talk about the baseline going up. If I take the baseline up, what is it going to mean in terms of the frequency of flooding at that house right there, or skyscraper, whatever you want to call it? If I take the base level up, hurricanes are going to come through nevertheless.
Like the baseline of where the houses are?
Yeah, but now I'm going to take the baseline, I'm going to go take it up a little bit. Because of sea level rise, this is now the sea level.
Then they're going to be less impacted?
Well, if it's higher sea level, they're going to be more or less impacted.
Well, if the houses are big, what I thought you were saying.
I'm sorry?
You said the baseline.
Yeah, the baseline being the water level.
Oh, okay. Then they'll be more impacted.
More impacted, more frequently. This house might be underwater, this house might be above water until you have a flooding event. This house might not have been subjected to the flooding event earlier. This one could have been. So the flooding zone, or the area that's highly impacted by these temporary ranges, keeps going up and up, probably in some sort of ratio exactly the slope of the angle here. So a lot of planning is done worried about not just the base sea level, but what's the extreme values. So we need to think about that a little bit. Okay, I'm gonna, any more questions about this Cincinnati t-shirt? You always get there's no more question part, don't you? Yeah, all right. Well, in that case, okay. Impact all places at the same. The nature of the coastline and isostatic response matters. The amount of infrastructure. Would anybody care? Does anybody really care if you go have this major hurricane along an unpopulated coast? I mean, there's no such thing as an unpopulated coast these days. But no, nobody would care so much. Okay, why am I thinking about this? I'm hammering this home because we're going to flip the assignment. Rather than worrying about what might have happened in the past, we're going to start thinking about planning for the future. So we're changing our time direction. We're getting into a little more nebulous thing, but this is the thing that's confronting us right now. So we looked at the past. The 120 meter sea level impacted a lot of Native American and other native peoples, but because they didn't build steel cities and they didn't build concrete walls and stuff, we don't have much evidence of that. So we don't know that much about the impact. So that's one of the reasons to go around, turn it around, and what we want to do is think about the scenario, the case, the possibility that there's a meter rise in the next century. Not quite in your lifetime, but you'll see half of it. If it happens. I'm not saying that's not a super prediction. All right, so it turns out that NOAA has provided us a site that gives you some insight to this prediction. What it's done is it's accommodated all of these ups and downs and the potential meter rise in sea level. Actually it's somewhat different. So you can see the paleogeography or the future geography. Present geography, here's the coastline. More water, it's up here. More water instead, it's still up there. I'm going to bring one of these up in a little bit. I'm going to walk through the deliverables right now because we're going to spend the rest of the time making sure everybody's comfortable with this website. Okay? There it is. If you can get to it now, you might want to. If not, we can figure out, I'll do some demos up here. To start with, find two coastal towns, one that's got a flat slope, one that's got a steep slope, relatively speaking. Tell me where they are. No big deal. Assume this, and then describe basically what's going to happen to that area in terms of water availability. This isn't necessarily the societal impacts. This is going to be just what the water does. This is well, if this happened in a populated area, it's one implication. If it happened in a non-populated area, it's a different implication. If you want to get ahead of the game, the third assignment is you're the town manager for one of these towns, or you're the town manager for them. How would you start planning for this possibility? So you see, we're easing into that. We just want to find out what might happen now. Next, we worry about what to do about it. All right, so I'm going to take their questions about what the assignment is. Like I said, I want to spend most of the rest of the time. We'll go to a variety of sites. You'll pick them. We'll go to them. We'll talk about it. And then you'll be here to go pick a couple sites on your own and do the same thing. Pretty simple, huh? I started you on a site that is a little more comprehensive than just sea level. It's NOAA, it's a government site, and Office of Coastal Management. So they're worried about, this is their job to worry about these things. So they've provided data and information. So in other words, it's one thing to look at a pretty picture of how the water might change. It's another to say it's a foot or a foot and a half or 5 feet. So town planners can actually access their predictions of the water change. Not how fast they change, but with a 1 foot water change, you get this and you get that. So there's a lot more information in here than our particular use. And you might just figure out some of the stuff they're doing, it's almost too confusing. We're gonna launch this thing rather than worry about the data, because we're not gonna try to be too formal about it, we're just conceptual. For which you're gonna get a map of the United States. And then I'm gonna ask you to pick your favorite coastal city.
San Francisco.
Or least favorite city, whichever you want. San Francisco. All right, San Francisco's over here. You think that's a steep coast or a shallow coast?
Steep. Shallow.
Would it depend on what part of the city you're talking about?
Probably.
All right, now I got to figure out how to do this without my handy dandy map. Okay, so you see a couple things here. You see the land. You see the water in blue, present day. You see some green areas which are low-lying. These are the areas that would be susceptible to high water. You see little place marks where they've given you a little more detail about things. So back to the nasty question I was asking her, this is a steep part of the coast. This is a fairly shallow part of the coast because you see there's something in there that's already susceptible to water level rise. Okay? Now, we can change this geography by moving this little bubble up and down here. And we want 1 meter, right? Which is how many feet? Don't know that it's 3.28 feet? It's not on the top of your head? Now it is, thank you. You'll thank me for that one day. Actually, I can change the units. That would be better, then we don't have to mess with it. Maybe I can change the units, maybe I can't. All right, so 4 feet, basically. What are the differences in San Francisco? Is that too broad? Should we zoom in on one area or another?
Probably zoom in on one area.
What area would you like to zoom in on?
The like more shallow area.
Just tell me to move the stick which way.
A little like that area right there.
Right in here?
Yeah.
South of the city proper,
Yeah.
okay? So we're zooming in. It's not San Francisco, it's Daly City, but right there, the town line between Daly City and San Francisco, right? Now we can see buildings, we can see infrastructure. We can see mountains. We can see docks. We can see areas that with a 4-foot rise in sea level would be wet. Now let's just, for chuckles, go down, take it back to normal. Okay, now we're going to go back up to the higher spots. What's the consensus of what's happened here?
With like steeper areas, those would be more affected by the sea level rise.
Well, the steep areas, they're not going to have more, they're not going to cover more areas, but you're going to get little areas like this, right? Let's go down again. And as we rise sea level, it's going to, I'm going to flood it all the way. And so one thing that's kind of curious is this zone right here, right? Watch what happens as we go up with a little bit of that. All of a sudden, it's wet, or potential to be wet. And it's not really on the coast. But it's low enough because the water can get in there. So this isn't just exactly the coast, it's the whole coastal system and the connected rivers. Yes, sir?
So is the green like a light level of flooding and the blues?
I think that's, they use slightly different terms of that, but basically this is not water, that's not water at this time. Watch this little pocket of blue here. Or not the time of the, you see, that little pocket now is green, but with some amount of rise, it converts to water. Does that help?
Yeah, so the green is not like flooding yet, but the blue is.
It might flood, but it's not underwater now. So it could be, it's on that nexus that if you get high enough water momentarily, you could get it wet. And so that makes this, and then all of a sudden this area turns out, because it's, even though it's not on the coast. Now it looks like there's a big highway in there. Let's zoom in again. All right. And there's a name for a lagoon here, which means that there's water there today. And that's the lowland, but this isn't. And you know what these things are? Round cylinders, look like tanks, are tanks, probably petroleum tanks. When the gas comes in to San Francisco, they put them in these storage tanks. And these storage tanks now seem to be high and dry. $10 feet, which is not necessarily next week. They're going to be at a little island. All right? Oh, the gentleman way in back. What city should we go to next? Or do we have any questions about this one before we jump someplace else? All right, so where do you want to go? Seattle. Big place, Seattle. You got to start thinking about where you want to go in Seattle. All West Coast cities. Seattle's got earthquakes, you know. All right, here we're coming into Puget Sound. Where are we going to go in Seattle? Lot of coastline here. Do you know that there's a major military base right about here? Might not know it, but if you want to buy a submarine, or you want to get thrown out of a place when you're trying to buy a submarine, it's over in here someplace. Okay, but where would you like to go? Up here? Or yeah, this area in here, around Everett. You know what's in Everett? They used to make 747s there. Okay. All right, so this is Everett. And what we want is Payne Field, which is, where's Payne Field? It's got to be right there. Makatiko. There's an airport in here someplace. Wow, look at that, we lost it. All right, going to Seattle again. We're going to go up to Mukilteo. All right, Mukilteo, Everett. All right, do you want to explore this little bay then? Is that the gist? All right, what's your prediction as we bring up water there? I can't find the Boeing plant. It's got to be there someplace because it's a big airport right there. So here's where they make 747s, or used to make 747s. And then they put them on the runway and they fly them away. But that's high and dry. This is an area over here. Describe it to me, please, a little bit. Green, yeah, it means what? Excuse me? It's kind of wet here. They talk about an island. And what do you reckon is this blue running through here? The big open water is blue, but what's this blue here? Excuse me? It's a river or stream, so that's already pretty much at sea level. There's no dam in between there. All right? What do you predict is going to happen as we take sea level up? Say it again? okay? Okay, so that's, all of this turned from, the green didn't necessarily increase, did it? But this green went from green to what? Blue, indicating that it went underwater. Now, in this case, the boundary of the water didn't go out over the land very much, did it? But the amount of water, you made sort of a bigger lake here. Okay, that's a different impact. Let's zoom in on something and see, oh, there was a good one. All right, so here's a little house, here's a little development, right? We're now looking at individual houses as a whole. They're stacked in there pretty high, right? Let's zoom in even further. It'll be helpful in this exercise if you do exactly what we're doing here, is start with a broad concept and then zoom in on someplace. Here's a housing development. We're going to raise the water level. And all of a sudden, how do you get to the housing development? I'm starting to get surrounded. I can't go that way because there's water. There's an interstate here, a bigger interstate here. There's the bridge that gets out of this housing development. In this water level, water's over the bridge. Okay. That's only 4 feet. Piece of cake. All right, so there's an implication. All of a sudden, this is not a viable, with that water level, this is, you either got to build a higher bridge, or you've got to start buying everybody rubber ducky rafts or something to get in. And we'll take it up just, I can't zoom in much longer. Oh yeah, I can make them a nice little island. Now, the advantages is, this becomes shorefront property and the real estate prices go up. Well, I'm being sarcastic, but not really. Right? Good tour of Seattle? Maxine, where would you like to go? You're gonna have to speak up because there's something I'm not hearing very well today. But what coastal city would you like to visit? Pick anyone. What's a city you've heard about and you've never wanted to visit, or a city you want to visit? On the coast, somewhere. Anywhere in North America. It's actually, this website's only good for the areas in the green are where this would work. You see this protrudes quite a ways inland, this protrudes inland, all of Seattle, and then down in here. So we want to go to the East Coast, the West Coast, the South Coast. Miami? Miami's down here. Miami's in a flat area, or is it a steep area? Do you have a particular part of Miami that's fun and not? Excuse me? Anywhere in North Miami? All right. All right, so we're looking at this. We've got blue. We've got little sprinklings of green, right? And what did the green mean in these other places? We had big patches of green in the other two. Here you've just got little, and the green meant it was potentially susceptible to flooding. Okay, but this is slightly different. Before we were looking at big areas changing. Now it's a dot here, a dot there, square here, square there. They're all square because that's the way they're building the land. So if I bring the water up, so what's going to happen, Maxine? Ooh, first of all, a lot of green areas showing up. Oh, now we got problems. And now we've got water getting in there. A lot of water here. This is because there's a big swamp on the backside. There's the city limits because that's swamp and they don't want to mess with it. We've got water intruding into the areas. We have all these areas that weren't flood. All of these areas around the little dots Oh, there wasn't much of a hint of problems here until we actually did this exercise, right? Oh, now we've drowned the whole thing. Is that a surprise in Florida? Not so much. Let's zoom out. And let's look at South Florida. We lost South Florida. 8 feet, that's 2.5 meters, that's a lot of water, but there it goes. Right? All right. What do we need to do now? Do we need to do another one of these, or do you need to get out of here, save your sanity? Or do you want me to say, if you want to get out of here, I'll turn my back and everybody can run, but I'll stay and do other exercises for somebody else that want to stay? You want to run? You want to stay? Let's do that. If you'd like to stay, I'll be happy to run through some more exercises to be sure you know what's up with this exercise. Let's go back and relook at it before you take off so that we're sure. Now that we've seen how to do this, let's go back and say, what am I asking again? Go here. We was just there. Find a shallow and a steep spot. Now, here's a thing where San Francisco showed us the shallow and steep nearby. So you're going to have to be specific. That's the be specific part. Exactly where are you? And then assume a 1 meter sea level rise, and you either change the thing or use 3.3 feet, which isn't a change, it's 3 or 4 feet. What are the changes to your town? What gets impacted? What goes from green to blue, or more green, or what? More water. And then speculate what's going to happen there. Zoom in on, like we did to where the oil terminal was, or where the housing development was, or usually there's factories and piers. There's a lot of commercial and residential real estate right on the coast. It's a prime thing. So zoom in on those and see what's happening for a couple examples. Okay? The next exercise will be, you own that, you're in that town, you're the town planner. What are you going to do to prevent that? Or how are you going to adapt to it? Or how are you going to plan for it? So you can start thinking about that now. All right, if you want to get out of here, I'm turning my back. Otherwise, I'll happy to work through another example. Sir.